Okay, so today I'm going to talk to you about the Zeeman Effect. And before I get started, I just want to say thank you to everybody that watched my video the first time and gave me some pretty good feedback. So hopefully I can use that and make a video that's a little bit more clear and concise. So I'll do my best to make those changes for you. The Zeeman Effect, in the most broad sense, is whenever you bring a magnetic field close to an atom. And what it does is it actually changes the behavior of that atom. Well, rather, it changes the behavior of the electrons within that atom. And it changes the locations, or rather the quantum levels that those electrons can be at. So that whenever an electron changes quantum levels, it actually is able to emit multiple different wavelengths of light. And that's called spectral line splitting. So that's kind of a brief overview of what we'll be talking about. Hopefully I can explain some of those terms in a little bit more depth. I don't expect you to understand everything right away. So whenever we look at a helium atom that I have here on the left, we can just look at it whenever there's no external magnetic field being applied. So we have our quantum levels, n equals 1, n equals 2, n equals 3. And as we increase in quantum number, we also increase in energy. So if we have an electron that's been excited from n equals 1 to n equals 3, then as that electron right here falls back down, it's going to emit some color or some wavelength of light. And the cool thing about that and quantum levels in themselves is that quantum levels are defined as specific locations or specific distances from the atom of where the electron will be. So it's not like a curved line where the electron could be at anywhere along that given point, and it could change any time. It's actually very specific quantum levels that determine where the electron will be. So the reason I told you that is because you can use these spectral lines, these wavelengths of light that are emitted, as a way to identify different elements. So if you remember from Chem 107, I believe, we burned elements like copper and it burned blue, or we burned lithium and it was red, or barium and it was green. And that's because the distance between these quantum levels, so the distance between, let's say, n equals 1 and n equals 3, is different for every single element. And that's due to electronegativity and the size of the atom and a few other things. But what it does is it actually changes the distance between those levels, and overall it changes the amount of energy that is released whenever an electron falls back down to its ground state. And that change in energy means a change in wavelength, thus a different color is emitted. Now, if we apply that to the Zeeman effect, then we can start to understand what happens whenever, doesn't want to up here, whatever happens whenever we apply a magnetic field, an external magnetic field. So the behavior of every single electron in an atom is determined by its angular momentum, its magnetic quantum number, and the direction in which it's spinning, and also how far away it is from the nucleus with the quantum number. But what happens whenever you bring in an external magnetic field is you actually start to manipulate that a little bit. And so whenever you start to change the influence or the behavior of an electron, then you actually change where it could possibly be located. And we map that or define that as like a sub quantum level. So we initially have n equals 1, but whenever we apply a magnetic field, we start to create sublevels, which could be n equals -1, 0, or 1. And this is what actually happens with helium. So I apply a magnetic field to helium, and this original level will actually split into three. Now, whenever an electron falls back down, so this electron falls back down to n equals 1, then it could fall down to -1, 0, or 1. And that means that there's three different amounts of energy that will be emitted when that electron falls back down. Thus, you have three different spectral lines that appear, and that is called spectral line splitting. So, with that spectral line splitting, you witness the Zeeman effect. The cool thing about the Zeeman effect, if I go into a little bit more detail, is that it actually is dependent on the strength of the magnetic field. So the number of lines that you see will actually be able to help you determine what the strength of that magnetic field is. I won't go into too much detail about this because it's a little bit more advanced, but the normal Zeeman effect is whenever you have a strong magnetic field and you actually say that the spin of the electron is 0. And that's represented here with C, and you see a lot more defined spectral lines, and it's a little bit more specific to those original quantum levels. But whenever you have a weak quantum or a weak magnetic field, and you say that the spin of that electron is non-zero, then you start to experience a lot of really different behaviors with the actual spectral line splitting that occurs. So that's a general overview of what the Zeeman effect is. Some ways that it's applied is pretty cool. So you actually can do something called laser cooling with the Zeeman effect. That's where you use lasers and you use different strengths of magnetic fields to actually decrease the amount of energy that's being released whenever an electron is falling back down. And you can actually use that continually decreasing the amount of energy within some kind of material, and you end up having something that's really close to absolute zero. So it's really cool. I don't know exactly how it works, but it's really cool that somebody was able to figure that out. Or you can actually use it in cosmic radiation and be able to figure out how much or how strong of a magnetic field something has that's producing this radiation. So if we talk about the sun, for example, you can figure out how strong a magnetic field is in a particular area of the sun based on energy that's been emitted and how that energy has been split by that magnetic field. And so you can use it to determine strength of magnetic fields. You can also use it to determine elements and different things like that. So hopefully I was able to give you a general overview of what the Zeeman effect is and why it occurs and what happens when it does. So thanks for watching, and hope you guys have a great rest of your semester and stay safe.